In this lesson, we're going to have a look at some more trig proofs, following on from some of the proofs that we did in the other trig chapters in year one. But now I've obviously got a few more identities to use. And we're also going to have a look at modelling some real life scenarios with trig as well. So this first proof, 2 sine theta over 2 cos theta over 2 times cos theta is the same as a half sine 2 theta. So I'm going to start with the left hand side. I quite like to start with either like the most complicated side and reduce it to the simpler side. That tends to be easier. So 2 sine theta over 2 cos theta over 2 times cos theta. Now the thing that I immediately notice here is this pattern here, 2 sine something cos something. We know that 2 sine A cos A, that is the same as sine 2A. That's one of the double angle formulae. Here it's just that A has been replaced with theta over 2. So this here I could actually replace with just sine, and then it's double this angle here. So it's just going to be sine theta. And I've still got the cos theta from before. So now I'm just left with sine theta cos theta. I've got to try and make it sine 2 theta. Well, again, sine theta cos theta, it's this pattern here again. It just doesn't have the 2 in front. So maybe I could write this as half of 2 sine theta cos theta. That would be the same. And now this thing here, 2 sine theta cos theta, we know that that is sine 2 theta, which is what we were asked to prove. So having those double angle formulae in your head and being able to spot them is really useful. The second one, part B, 1 plus cos 4 theta equals 2 cos squared 2 theta. Let's just bring this down with us. So we've got to prove this result. So again, I think I'm going to start at the left-hand side. Now, if we've got something in here which isn't just theta or 2 theta, which we've got formulae for, 4 theta is a good way of splitting up as 2 theta plus 2 theta. Before, we've dealt with things like cos 3 theta, and we split it up as 2 theta plus theta. So here what I'm going to do is split this up as cos of 2 theta plus 2 theta. And then I can use the addition formula to split this up. So this is going to become cos 2 theta minus sine 2 theta sine 2 theta, which is then 1 plus cos squared 2 theta minus sine squared 2 theta. I suppose you could have used the double angle formula instead of the addition formula. You could have written it as cos 2 times 2 theta. Could have used it that way instead. But we get to this result here. Our answer, we just want to have cos squared. We don't want any sine squareds. So we can just use sine squared plus cos squared equals 1 to rewrite this as 1 minus cos squared 2 theta. And then when I simplify this, I'm just going to get 2 cos squared theta, which is the result we were after. So for this next one, again, I'm going to start with the more complicated side and try and simplify it to the simpler side. So this time I'm going to start with the right hand side. So I'm going to start with 2 divided by cot theta minus tan theta. Okay, and I've got to try and reduce that to just tan 2 theta. Let's try and rewrite this in a different way then. So I'm going to change the bottom. Instead of cot, I'm going to write that as cos theta over sine theta, because remember cot is just 1 over tan, minus tan theta, which is obviously sine theta, over cos theta. Okay. Now, with the denominator, I'm going to just try and combine these into one fraction on the bottom. So I'm going to make a common denominator of sine theta cos theta, which obviously means I'm going to have to times this side by cos and this side by sine. So I'm going to end up with cos squared theta minus sine squared theta over sine theta cos theta. Okay. Now, I'm not really a fan of having fractions on the bottom of a fraction. This is starting to look a bit silly, so I'm just going to rewrite it. 2 divided by this is the same as 2 times 1 over this. So that would be 2 times sine theta cos theta over cos squared theta minus sine squared theta. Okay, so dividing is the same as timesing by the reciprocal. Okay, now hopefully the top of this fraction and the bottom of this fraction are jumping out at you as being some double angle formulae. So the top one, sine theta cos theta. Well, sine 2 theta is 2 sine theta cos theta. So I can rewrite this as half sine 2 theta on top. In a minute, these will cancel out anyway because I've got the 2 at the front. And the bottom, cos squared minus sine squared, that is cos 2 theta. So I'm just now left with sine 2 theta over cos 2 theta, because the 2 and the half times together to make 1, which is then tan 2 theta. And there we are. So you can always do these in another way. Of course, you can always go backwards. You can start at the left and go to the right and vice versa. But don't think that my solutions here are the only way you could do these questions. There's always multiple ways of doing them. For this last one, prove that root 3 cos 4 theta plus sine 4 theta equals 2 cos 4 theta minus pi over 6. So this is following a similar format to the harmonic form question that we did last lesson. So you could take the left-hand side and rewrite it as r cos 4 theta minus alpha and solve it, just like we did last lesson, and you should get the answer on the right. But I think it's probably actually easier to start with the right here, expand it using an addition formula, and prove that you get what's on the left. So that's what I'm going to do. So if I take the right-hand side, so I've got 2 cos 4 theta minus pi over 6. Let's expand it. So it's going to be 2 times cos 4 theta cos pi by 6 plus sine 4 theta sine pi over 6. Then I can work out cos pi over 6 as a number and sine pi over 6 as a number. So this is then going to be root 3 over 2 cos 4 theta plus half sine 4 theta, and expand it by 2, so it's root 3 cos 4 theta plus sine 4 theta. And then that's the answer that they're after. So doing trig proofs is mainly about basically just about practicing and looking at the solutions and seeing how they did it if you're unsure, really. There's not really a substitute for just doing lots of them. There's no real trick. But the questions that I've picked out for you to have a go at on trig proofs, exercise 7F, questions 1 and 2. There's several proofs in there that you can have a go at. I'll also use the word solutions to help you. What we're going to have a look at next is modelling with trigonometry. This is quite a sort of typical example of the sort of problem you might come across. So here we have got the model of a Ferris wheel is what we're going to look at. Now the first part of the question is giving you a hint as to how we can model it. It says express 10 cos theta minus 3 sine theta in the form r cos theta plus alpha. So we're going to do exactly the same method as we would do normally with this one. So I'm going to just set them equal to each other and then expand one side. So I'm going to expand the right hand side. So that's now r times cos theta cos alpha minus sine theta sine alpha. Compare coefficients. So 10, which is what I'm timesing by cos theta, is going to be r cos alpha. And minus 3 would then be, actually I can do it as just 3 rather than that, because 3 is what I'm timesing by negative sine theta. Negative sine theta is times by r sine alpha. Then we could do our normal solving. So r sine alpha is 3, r cos alpha is 10, so r is going to be 3 squared plus 10 squared, square rooted. which is root 109. And then alpha is going to be inverse tan of opposite over adjacent, so 3 over 10, which is 16.7 degrees. So we can rewrite this as root 109 times cos theta plus alpha, so plus 16.7 degrees. Okay, so that's my answer to the first bit. Now, the height above ground, h, of a passenger on a Ferris wheel at t minutes after the wheel starts turning is modelled by this equation here. Okay. Notice in this question that they are following on from the previous part. We've got minus 10 cos an angle plus 3 sine an angle. So that's basically this equation here multiplied by minus 1. Okay. So I'll have to use that later. Figure 3 shows a graph of h against t for 2 complete cycles of the wheel. So they're just going up and down and up and down, as you'd expect. Given that the initial height of the passenger above the ground is 1 meter, find the complete equation for the model. So this is what they've given us as the equation for now. But it's got this unknown value, alpha, in here. But we're told that the initial height, so initial height means that when t is 0, since the height is 1 meter, so h is 1 meter. So I can just substitute that in. So 1 equals alpha minus 10 cos of 0, because 80 times 0, plus 3 sine 0. And if I solve that, I will get alpha equals 11, because this is going to be 1 minus 10 cos 0, so that would be minus 10. There we go, so alpha must be 11. So our complete equation is going to be h equals 11 minus 10 cos 80t plus 3 sine 80t. So that's our answer for the second bit. Part B, so part 2 of question B, hence find the maximum height of the passenger above the ground. Well, this is where our answer to the previous bit comes in handy. So we've got 11 minus that equation there, which is similar to what we had before. We had the equation 10 cos theta minus 3 sine theta. So actually what I could write this as, h equals 11 minus 10 cos 80t minus 3 sine 80t. So now that is in the same format as I had before, because it's 10 cos minus 3 sine. So I could now replace that bit in the bracket with what we worked out earlier. So minus root 109 cos, now instead of theta is 80t, so 80t plus 16.7. So we can rewrite our equation like that, just using what we worked out before. Now we can use this to find the maximum height. So the maximum of this function, we talked about this when we did some examples last lesson, the maximum of this trig function here is going to be root 109, because cos, that alternates between 1 and minus 1. So we times it by root 109, that's now going to alternate between 109 and minus 109. Okay, so this bit here could be from negative 109 to positive root 109. Now to make the maximum value of h, it's actually going to be a maximum when this is negative 109, because then we would have 11 subtract minus root 109. So the maximum height is going to be 11 minus root 109, or 11 plus root 109, which gives me a height of 21.4 meters. Okay, so that's the answer for that part there, 21.4 meters. Okay. Find the time taken to the nearest second for the passenger to reach the maximum height on the second cycle. Okay, so I'm just going to do my working for C down here. So the maximum height, we said that was when this bit of the trig function was negative root 109. So minus root 109 was that bit there. Okay, or we could basically say that's when the trig function, the cos bit, is equal to negative 1. Okay, because although we wanted the maximum height, that was actually when this was at its minimum, and cos is at a minimum when it's at minus 1. So this is what we've got to solve. Now, to actually go through and solve that, let's just find out what this bit here is. So 80t plus 16.7 is going to be inverse cos of minus 1. Just do this in degrees. So solutions, we could have 180, or we could have 540, and so on. It says for the second cycle, so I'm expecting it's going to be the 540 value. Then we can use this to find t. So you can do 180 minus 16.7 divided by 80. So we get 2.04 is one solution. And the next one, 540 minus 16.7 divided by 80, 6.54. Okay. So this 180 is the first cycle. Maybe let's think about the cos graph to help us here. So there's one cycle. And here's the second cycle. And we're looking for when it is minus 1. So we're looking for these 2 points here. So that's the first one at 180. Then on the second cycle, it's 540. So it's when this bit here is equal to 540 degrees. That's the second time that cos is minus 1. So 6.54, that's going to be the time I'm looking for. 6.54, so that is 6 minutes. And then we've got 0.54 of a minute. So that's 0.54 times 60, which is 32 seconds. Okay, there we go. 6 minutes and 32 seconds will be our answer there. Right, the last part then. It is decided to increase the profits, the speed of the wheel is going to be increased. How would you adapt the equation to model this increase in speed? Well, all we're going to do for this, if our model currently looks like maybe this equation here in yellow, or the one underneath it here is fine too, the thing that would make it cycle around quicker is basically we're squashing the graph by more. So instead of a graph that looks like this, we want it to look like that maybe. That would be twice the speed. Remember, when we're doing graph transformations, this is going from f of x to f of, maybe it's f of 2x, to squash it by 2. So basically what we want to do is change the 80 to a higher number. Okay, so this number here. Okay, so I'm not going to write it down, but increase the coefficient of t. So instead of 80, you could turn it into 160 if you wanted to double the speed. Okay. So there's an exercise focusing on modelling with trig, which is exercise 7G. You can have a go at that, and again, use the work solutions to help you, but they normally use harmonic form, and then you're using that to find minimums and maximums and solving equations to find times normally.